In this lecture, we're going to calculate the next position for the enemy. At the moment, the patrol component sends the enemy to the start of the path. This component should be able to calculate the next position along the spline. This information will be set to the patrol state to move the enemy. So, our next step is to begin calculating the next position. Let's view the patrol component. In this component, we have a method called getNextPosition to get the next position. Within this method, we're calling the evaluatePosition method to get a position from the spline. As mentioned in an earlier lecture, this method accepts a value from 0 to 1. 0 represents the starting point on the spline. 1 represents the ending point on the spline. Therefore, we must pass in numbers from 0 to 1 to get various positions. Preferably, the numbers should gradually ascend to 1. After reaching 1, we would reset the number to 0. At the moment, the same value gets passed in. Therefore, the same position gets returned. Let's change this behavior by creating a variable. At the top of the class, define a private float variable called splinePosition. The value will be 0f. Next, head back to the getNextPosition method. Pass this variable into the evaluatePosition method. By outsourcing the value into a variable, we can update the variable to get a different value from the evaluatePosition method. The next step becomes obvious. We must update the splinePosition variable. After updating this method, let's create a new method for calculating the position. Below this method, define a public method called calculateNextPosition. Within this method, let's set the splinePosition variable to the following value: splinePosition plus time.deltaTime. We're updating the splinePosition variable with the deltaTime variable. As a reminder, the deltaTime variable measures the time between frames. As each frame passes, we'll increment the position variable with the time. There's a shortcut for writing this line of code. C# supports an operator called addition assignment. If we add a number to an existing variable, we can use this operator to write less code. Let me show you how. Before the assignment operator, add the plus symbol. Next, remove the position variable from the equation. This line of code performs the same operation as before. The C# language will add the value on the right side of the operator to the value on the left side of the operator. The time will be added to the position. If this line is hard to read, you can always revert the code to the original solution. After setting the position, we should check for a value greater than 1. If we pass in a value greater than 1 to the evaluatePosition method, Unity will always return the endpoint of a spline. We should reset the position variable to continue moving the agent. Otherwise, they'll be stuck in the same position forever. Add a conditional statement with the following condition: splinePosition greater than 1f. Inside this conditional statement, let's set the splinePosition variable to 0f. Lastly, let's print the splinePosition variable with the print method. If we did everything right, the variable should start from 0 and move up to 1. After reaching 1, the variable will be reset to 0. To test our work, we must call this method from the patrol state. Switch over to this file. At the bottom of the updateState method, call the enemy.patrolComponent.calculateNextPosition method. Let's go back to Unity. Next, try playing the game. After the enemies move into their respective positions, the patrol component will begin logging values. As you can see, the range of numbers is always between 0 and 1. That's great. We can start moving the enemy with these values. Let's start updating the patrol state.